Okay, so here is another quadratic model projectile motion question. And we're going to do this equation, and again I explained it in another video, and I'll write it above the equation here, just to remind us of what it is. Okay, so the height with respect to time is negative 16t squared plus v of 0t plus h of 0. And again, I've already underlined what each part means. Okay. So, again, if you need to see a more in-depth explanation of that, go back and watch one of my other projectile motion or quadratic modeling problems. All right, number 2. A ball is thrown vertically upwards at initial velocity. Ooh, that sounds important. Initial velocity of 48 feet per second. If the ball started from a height, so it started from a height of 8 feet off the ground, determine the time it will take for the ball to hit the ground. Okay, so we want to determine the time. That's eventually what we want to do. Okay, so in this problem, again, I have h of t equals negative 16t squared. That doesn't change. That's the effect of gravity on an object. Okay, initial velocity, I was given 48 feet per second, so we just put 48t. And it started 8 feet off the ground, so 8. Okay. So then, it says determine the time. So it wants to know the time it takes for the ball to go up, come back down, and hit the ground. So when it hits the ground, what's the height going to be? Hopefully you say, well, the height should be 0, right? Because the ground is at 0 feet. So guess what I'm going to do? I'm going to plug in 0 for h of t, meaning the height. So this is all going to become 0, because I want to find the time when the height is 0. Okay? So that's the goal. I want to find where the height is 0, meaning I need to find out what time that's at. Okay? Wow, this looks a lot like a quadratic equation. And you'd be right. Okay, there's many different ways we could solve this. The way Mr. Schwann's going to do it is try to make this problem as simple as possible. He notices that 16, 48, and 8, I could take out an 8 from all of them. Okay? So I'm left with negative 2t squared plus 6t and then plus 1. Okay? So then Mr. Schwann's going to look at this and say, how are we going to solve this? Well, let's try x-factor chart. Let's see if that works. Okay, so I'm doing it from the red. So on top goes negative 2. On the bottom goes 6. Will anything multiply to give me negative 2 but add to give me 6? Unfortunately, no, that won't work. Right? Because the only options to get negative 2 are 1 and 2, and then we'll never add up to 6. Okay, so x factoring won't work. Well, I could try to complete the square, but unfortunately there's a number in front of t squared, and 6, that just looks confusing. I don't want to have to complete the square. Can't do square roots, so the only other option is quadratic formula. So that's what we got to do. Okay, here we go. Hopefully you all remember the quadratic formula. Just in case you don't, I'll write it up on top here. X equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, so let's plug that into the equation. Here we go. So, just to label it quickly here, a equals negative 2, b equals 6, c equals 1. Okay. So, we're going to get x equals negative 6 plus or minus the square root of 6 squared minus 4 times negative 2 times 1 all over 2 times negative 2. Okay, so if we work through that, it's going to be negative 6 plus or minus. That's going to give me 36. Negative 4 times negative 2 is positive 8. Positive 8 times 1 is plus 8. And then 2 times negative 2 is negative 4. Okay. All right, let's continue. 36 plus 8 is going to give me 44, if I'm doing my math right. Okay. Over negative 4. Okay. Now, usually Mr. Schwann would say, I don't want decimals. Okay. However, when I'm dealing with real-life problems such as projectile motion and quadratic modeling, I do actually want you to take a decimal this time. Okay. So I'm going to take the square root of 44, and that's going to give me something like, so negative 6 plus or minus, that's going to give me 6.63 is what we'll say. All right, 6.63 over negative 4. So I have two different answers here. Okay, so I have negative 6 plus 6.63 over negative 4, and I have negative 6 minus 6.63 over negative 4. Okay, so let's go ahead and plug in those answers. Here we go. So negative 6 plus 6.63 divided by negative 4 gives me an answer for time of negative 0.1575. Okay, so that's for that one. Let's try negative 6 minus 6.63. And then divided by negative 4, I get a time of 3.1575. Okay? So, looking at my two answers that I've just got for this, okay, I have two different times. In real life, can I have negative time, right? Can I ever go back in time? So, unless you show me the sorcery you're using, we're going to go ahead and make the assumption that negative time does not exist. So, we're going to go ahead and cross out the negative answer. So, the only true answer is the positive 3.1575. So, how long will it take for the ball to hit the ground? 3.1575 seconds is how long it will take. Okay? So, that's another great example of quadratic modeling and projectile motion. Try your best with the rest of these. Make sure you read the questions and what it's asking for. And there you go.